Hello there and welcome to A-Level Further Maths. Here we're looking at Chapter 3, Improper Integrals, so we can answer questions from exercise 3a. So what is an improper integral first? Well, let's just define what a definite integral is, a proper kind of sort of integral that we've definitely seen before. So it's where we have a curve and we want to find out the area under the curve in between two boundaries. We'll call them A and B. And we'd look to find this area by integrating the function of the curve in between A and B. So why is this a definite integral? Well, it's because f of c is defined for all c that exist in between a and b. Now what this is saying, this little mathematical sentence here, is that every c that is existing in between a and b, so every number that I'm going to call letter c, between a and b is defined. So for example, if I set c to be this value here, then there is an output for c that will be at approximately this point on the y-axis. And I could choose a different point for c, maybe c is over here, and it's always going to be defined for every single value in between a and b. I'll call it letter c, and that value c, or f of c, is defined. It's also a definite integral because the curve is continuous. There's no jumps in the curve from one point to another, so it's a definite integral because of that reason as well. And also it's a definite integral because a and b are finite values. It's not like I've got an infinity symbol on the top or the bottom of my integral here. So these are three components that definitely make this integral a definite integral. So what would define an improper integral then? Well, let me show you an example of one. Let's take the 1 over x curve and find the area between 0 to b. Now, why would that be an improper integral? Well, it'd be an improper integral because f of 0 does not exist. It tends towards infinity. So this, I can't find what f of 0 is. It's a bit like this first feature of the definite integral in the case that there is a value for c, and that value is 0, where f of c is not defined. F of 0 is not defined here, so that makes it an improper integral. Now, it doesn't just have to be one of the numbers on the boundaries or on the limits of my integral. If there's any value in between 0 to b, or between your two limits, where the graph does not exist, or the function isn't defined, then it's also an improper integral. Another example of an improper integral is where I do an integral up to infinity. So if I do an integral from a up to infinity, it doesn't have to be on any particularly interesting curve, it doesn't have to be on the 1 over x curve. Any integral where I'm having to integrate between infinity or even minus infinity up to something is an improper integral as well. So I'm now going to show you how we solve questions to do with improper integrals. So let's get going. So the examples I'm going to show you are these two here. So we're going to evaluate each improper integral or show that it is not convergent. So sometimes in these questions, the answer to what this area is when it tends up to infinity or tends towards a point to 0 where it's not defined is that the answer to that area is infinity, like it's too big to measure. The area will just carry on for infinity. So that's what it means when it says does not converge. It means that the area defined by that integral is infinite. So let's have a go at question 1 then. The integral from 1 to infinity of 1 over x squared dx. Now the way that I deal with this infinity here is I introduce a limit. A bit like you've seen in differentiation already, where you set the limit of h to 0, I'm going to set the limit of t to infinity, and then I'm going to do my integration from 1 up to that value t. So what I'm going to do is I'm going to work inside the brackets for the majority of this question, doing the integration, putting t in as one of the limits, and then the final thing I'll do is I'll consider, okay, well, what will happen if t becomes a very, very big number or tends to infinity? So let's work inside the brackets first. The first thing I need to do is do this integration. So that will give me minus 1 over x between the boundaries of 1 and t. The next thing I do with this integral is substitute in the limits. So that'll be minus 1 over t, and then it'll be minus 1, so that'll make it plus 1. Now once I've done the integration and once I've plugged in t, I now apply the limit. So I'm now going to consider what will happen as t becomes a very, very big number or tends to infinity. Well, in my function, I've got minus 1 over t. So what will minus 1 over a very, very big number become? Well, it will become roughly nothing. It will become so small that it won't actually affect this 1 at all. And when it becomes infinitely big, it won't affect this 1 at all. So as t gets really, really big, the function of minus 1 over t tends towards 0. So the total value of this limit is equal to 1. So the answer to this question is 1. So we say that it does converge as it is equal to 1. So the answer to part A is 1. So you've seen here how we're now going to deal with limits where we go up to infinity. We replace the infinity symbol with the letter t and then put lim as t tends towards infinity at the front. Do the integration in the brackets, and then when you've got your answer, consider what will this be equal to when t tends towards infinity. Let's have a go at the second question. It looks very similar, but something different happens at the end of it. So that's why I've used these two particular questions. So the first thing I'll do is I'll sort out the infinity symbol by introducing a limit. The limit of t tending towards infinity of the integral from 1 up to t of 1 over x dx. Let's now do the integration, and the integral of 1 over x is ln x. So it would be the limit as t tends towards infinity of ln x between t and 1. So substitute those limits in and we get ln t, because when you do ln of 1, that's 0, so I don't need to write minus ln 1 because that's just 0. So now what I'm going to consider, now that I've done the integration and substituted it in the limits, is I'm going to consider what will happen to ln of t as t becomes a very, very big number. What happens to ln t as t tends towards infinity? Well, the ln graph is an increasing graph and it will continue increasing infinitely. So actually the answer to this is that the limit as t tends towards infinity of ln t will tend towards infinity. I'm reluctant to say is equal to infinity. Sometimes it is, but really it's more like tends towards infinity as the t tends towards infinity. So the answer to this integral is that it does not converge as it tends towards infinity. Also, if there's a question where it tends towards minus infinity, then you would say it does not converge either. So we just write here that it tends towards infinity and it does not converge. So this one, the first one that we did here, question A was convergent, and question B here is not convergent. Let's have a go at these three questions here where we're going to apply the techniques that we've just learnt. So in this question, we've got an integral from 2 to 0 of x over the square root of 4 minus x squared. Now, why would we consider this to be an improper integral? And that's what you've got to do when you first approach a question like this. Why is this integral an improper integral? Well, you might think that it's something to do with the 0 because we've got to divide by x at some point and you can't ever divide by 0. Well, yes, you're correct, but actually that's going to interfere with why there's a 2 on the top boundary. If you put 2 into this function, you're going to get a 0 on the bottom. So you strictly shouldn't be substituting in 2 into this function because the graph does not exist when x equals 2. So at x equals 2, the graph will not be defined. So what we need to do then is we need to replace the 2 with a t on the top and then write lim as t tends towards the number 2. Then we're going to do the integration here. It's going to be integration by substitution. We're going to set u equal to 4 minus x squared. Then we need to work out what dx will be substituted by. So I'll differentiate my substitution and just rearrange it a little bit so I get dx equals minus 1 over 2x du, and what that will do is it will cancel out with the x on the top there. I also need to consider what will happen to my limits whenever I use a substitution. So when x is equal to t and I substitute t into my substitution, then u is going to become 4 minus t squared. and when x is equal to 0, the bottom limit is going to be x equals 0. Put x equals 0 into your substitution, and you get u equals 4. So now my new boundaries are between 4 minus t squared and 4. So this is what you get in the next stage of your workings out. You can see the boundaries have changed. The x on the top of the integral is still there. I'll then divide by the square root of my substitution and then multiply that by what you substitute dx with, and that's minus 1 over 2x du. The x's on the top and the bottom there will cancel out. And in fact, what you can do with multipliers is you can actually factorize them out of the limit and the integral all together. So I'm going to simplify by taking minus half out of the integral, and then the next step I'm going to take it out of the limit altogether, and I'm going to integrate 1 over root u. And that will integrate to 2 root u. And then I'm going to put the boundaries in between 4 minus t squared to 4. And then I'm going to substitute these in. I'm going to factorize the 2 out to the front. So that's why the half has disappeared, because I factorized the 2 out to the front. And now that I've got it to this stage here, I've done my integration, I've substituted in the limits. I'm now going to consider what will happen as t goes towards 2. If we think about it, as t moves closer and closer towards 2, then 4 minus the square root of that squared value will effectively just become 0. So this answer to the start here is effectively going to tend towards 0. So the answer to this question is going to be minus, or because the minus is at the front there, of 0 minus 2. So that's going to be 2 as the answer. So the answer to question A is 2. Let's move on to the next one. The next question is the integral from minus 1 up to 2 of 1 over x squared dx. Well, the minus 1 substituted in, that will be fine. The 2 substituted in, that will be fine. But it's in between the two bounds, we have the number 0 that you could not substitute in to 1 over x squared. So consider why we have an improper integral here. Well, it's because at the point where x equals 0, the graph will not be defined. And if it was a definite integral, then you should be able to define every single point between minus 1 to 2. So how are we going to approach this question? Well, this is the graph for 1 over x squared, and we're working out the integral between the boundary of minus 1 to 2. But we have an interesting point when x is equal to 0. So that's where I'm going to have to bring in my value t, and I'm going to separate this integral into two separate integrals, the integral for A and the integral for part B. So the integral for part B will be the limit as t tends towards infinity on the negative, so t tends towards 0 on the negative side. Now it's really important, it's actually not in the textbook, this notation here, but we are approaching 0 from the left hand side, from the negative numbers side. So that's why there's a power of a negative on the 0 there, because I'm approaching it from the negative side. So this is approaching from the negative side. And then we'll do that integral. So we're going to work out part A. So that'll be in between minus 1 to t, or 0 effectively, of this curve. And then the second part will be part B, but I'm going to be approaching 0 from the positive side here. That's why there needs to be a power of plus on my limit here. So there are two different types of limits. One's coming from the negative side, one's coming from the positive side. And you'll see later on why that is important. And the integral that we're going to be doing here is in between 2 and down to t on the integral for the area for B. The next thing we need to do then is the integration. So integrate your functions inside their limits, and then substitute in your t's, your ones, your minus ones, and your twos. So get that substituted in, and now we'll start to consider the limits. So we've got minus 1 over t when we substitute t. We've got the triple negative happening when we've got the minus 1 here. We've got the minus a half here, and then we've got the double negative that will be here, that will be 1 over t. Now this is where it's really important that we have the two different types of limits. It will be the limit going towards 0 on the negative side and the limits going towards 0 on the positive side. So let's just consider what we've got here. We've got the 1 over x graph that will look like this. Now on this first one here, we've got the limit of 1 over t as t tends towards 0 on the minus side. So that will take it towards negative infinity, but then there'll be a negative sign in front of it, so that'll take it towards positive infinity actually. And then with the limit as t tends towards 0 on the positive side on this expression here, that's also going to take it towards positive infinity as well. So both of these expressions here will be taking this function towards positive infinity. Just because one of them is minus 1 over t and one of them is plus 1 over t does not necessarily mean that they cancel out. I was pretty stumped in a lesson a couple of years ago when my students suggested this to me, and it's the reason is because we're approaching the limit from different sides on the function, one from the negative side, one from the positive side, which actually mean they can't cancel each other out. One, because they're different types of limits, and two, because actually when you approach 0 from the negative side from minus 1 over t, that's actually tending towards positive infinity, and so is this one here. So the answer to this question is that it does not converge. It is divergent, or it does not converge. There's no answer to this question. It will tend towards infinity, or this area in between minus 1 and 2 on the 1 over x squared graph will equal will be something convergent, but not convergent, so it will become infinity. So it does not converge. Okay, let's move on to the last question. That will be question C. It's in between minus infinity to infinity. Now, what are we going to do here? Well, let's just have a quick look at what we're going to do with this graph. This is the graph for x e to the minus x squared. You don't need to know what this graph looks like. I just thought I'd give us a visual of what we're going to be doing here. Now, what I'm going to be doing is I'm going to be splitting this integral into two different integrations. I'm going to be splitting it at 0 and then working out the integration up to infinity on the right hand side, and then splitting it up from 0 down to minus infinity on the left hand side. And I'll add these two integrals together, and then we've got the whole range from minus infinity to infinity. Doesn't matter that I've broken up the function at 0. Sometimes it might be more sensible to break up the function at 1 or at minus 1, where there's a natural changeover from positive to negative or anything else. So that's what we're going to do. To do this integral here, we're going to go from minus infinity to infinity by breaking it into two components, one from 0 to infinity and one from minus infinity up to 0. So just like that. Okay, so the next thing to do will be to do the integration. We're going to be using the integral of u by substitution of u equals t squared, and I'm just going to jump straight to the answer here. If you need more practice at integrating by substitution, then please check out another video. There's plenty of them on integration by substitution. I'm just going to jump straight to the answer here. So this is the answer to the first one, minus a half e to the minus x squared, and this is the answer to the second one. Let's now substitute in so the reason I haven't put any pluses or minuses on these limits here is because the only way of tending towards infinity will be on the positive side. So it's kind of like this pointless writing it. The only way you can tend towards minus infinity is on the negative side. So you'll just, that would be pointless saying it. So to simplify, let's now substitute in the boundaries. So when you substitute in we've simplified first, which is to take out the minus half to the front of both of these integrals, which makes it a bit easier when we then substitute in the boundaries. So substitute in t first and then substitute in 0. Remember, e to the 0 is 1, so don't forget that that exists. And what we'll do now is we'll now start to think what will happen as t tends towards infinity or t tends towards minus infinity. Well, the first one here, remember the shape of the e graph? e to the minus something graph will look something like this. It will tend towards 0 as t gets very, very big. This is the e to the minus t squared graph. So as t tends towards infinity, this function here will tend towards 0. As will this function here, because if it's minus infinity that t is tending towards, then t squared will tend towards positive infinity. So it's exactly the same kind of thing that will happen on this graph here. So both of these e's will just tend towards 0, and then tidy your answer up, and we get 0. So the answer to this question is just 0. Now, why has that happened? Well, if we have a look at the original graph, x e to the minus x squared, we've got this area up here, area A, and this area down here, area B, and you can see the rotational symmetry from one side of the graph to another. This will give us a positive area, this will give us a negative area, and the two sides are completely equal to each other. When you rotate it round, you'll get exactly the same graph again. So because they're perfectly complementary sections of the graph, this negative area will cancel out this positive area and we will get 0. So there we are, that's how we do improper integrals. So I'd like you to pause the video now and have a go at this question. It's in two parts here. Pause the video, give this one a go. Okay, so let's get started on this question then. We need to just integrate this curve first. So it's going to be substitution. U will equal 7 minus 3x. Let's work out what dx needs to be replaced by now. So du by dx will equal minus 3. And then need to rearrange it to make dx the subject. It will be minus a third du equals dx. So dx will be replaced with minus a third du, and u will be replaced with 7 minus 3x will be replaced by u. So the integral here is going to be u to the minus 2. I'll factorise the minus third to the front, and then it'll be du. So let's now answer this. Increase the power by 1, divide by the new power. So the increase will be up to minus 1, and it will be divide by the new power, so that would be minus 1 at the front, plus c. So it's going to be positive third, u to the minus 1 plus c. So the answer to this integral will be 1/3 times 1 over 7 minus 3x plus c. So I'll times those two fractions together. So it's going to be 1 over 21 minus 9x plus c. So there we are, that's the answer for that question. And now we'll do part B. So hence show that the integral between 2 to minus infinity of this expression here converges. What I do want to just do is I do want to check that I'm not going to have any issues going past 2. So the number that I couldn't integrate on this curve here will be 7 over 3. And 7 over 3 is a number that's higher than 2, so when I go from 2 down to minus infinity, I should be okay, so that's fine. So what I'm then going to do is I'm going to write this as equal to the limit as t tends towards minus infinity of the integral from 2 to t of 1 over 7 minus 3x squared dx. The answer to this integral was worked out in the previous question, so I'll just put that in. It's going to be 1 over 21 minus 9x, and I'm going to put that in between the boundary of 2 to t. Let's now substitute those boundaries in. And it's going to be substituting 2 in, that would be 18, so that would be 21 minus 18, that would be a third. Minus t substituted in, so that would be 1 over 21 minus 9t. And now we'll think what will happen as t tends towards minus infinity. Well, if t tends towards minus infinity, then minus 9t will tend towards positive infinity. So it would be 21 plus infinity, so 1 over 21 plus infinity, well, that would just head towards 0, 21 additions faster, so actually it won't make any difference at all. Show that it will converge towards the number of 1/3. So there we are, that's the answer to this question. Make sure you have a go at plenty of the questions from exercise 3A on page 56. Hopefully you found this video helpful. Feel free to rewind it and just watch some of the different components again. But yeah, thanks very much for watching, and hopefully you found this useful.